today's lesson is to graph from an equation, and then sometimes instead of graphing, we may need to build a table, or we may need to build a table in addition to graphing. So we're going to talk about how to do all those different things. And to begin today, first we want to recall all of our different words that we have for slope. When we think of slope, remember it is our m value in this slope-intercept equation. It's how we move when we think about the rise over the run, so that up and down movement, and then our left and right movement. We can also think of it as the change of y or over the change of x. And then we also can say it is the rate of change. Sometimes you might just hear the word rate. Those are all different ways of thinking of slope. And remember, they're all interchangeable. And so when we talk about graphing from the slope-intercept equation, we like to help ourselves with the m and the b, so our slope and our y-intercept, for hints. When we think of the slope, that m, highlighter, it's how we move. So m is our movement. And then that b, the y-intercept, is our beginning. B is for our beginning. So we begin at the y-intercept, and then I'm gonna move. So this is gonna be my first thing I do, and then my movement is my second thing. When we talk about movement, we're gonna really rely on that rise over run thought process. And so Ms. Morose made us a little helpful strategy step. So if we need that, we pull out our y-intercept and the slope, so identifying our m and our b, plot the y, so that's our beginning, and then use the slope for our movement. We're gonna move, drop a point, move, drop a point, and repeat that process. So let's see what that looks like. First, when we are talking about slope and y-intercept, slope, we're drawing in those triangle movements. It's that rise over run, remember. And then the y-intercept is where it crosses the y-axis. So we want to keep that in mind while we're graphing. And our steps told us the first thing is to identify my slope and my y-intercept. I know my standard equation is y equals mx plus b. My slope is that m, so my slope is 2. When we say define, we're going to define how we would do our rise over run. So it has to be a fraction. 2 as a fraction is 2 over 1. Because it is a positive 2, that's up, and a positive 1, right. So we'll move 2 up, 1 to the right. And then I also need to identify my y-intercept, or the b value. That value is a positive 3. So that's going to be where it crosses my y-axis. So then we graph. We start with the beginning. So I'm going to start with my y-intercept. It crosses the y-axis at 3. So I put my first point at 3 on that y-axis. Then I'm going to move. So I need to move, and we already defined how I'll move. From my point, I move up 2, right 1. Up 2, right 1, and I drop a point. From that new spot, I move the same way. Up 2, right 1, drop a point. Up 2, right 1, drop a point. Once I've dropped enough points, I can go ahead and use a ruler to connect these in a nice straight line. My line needs to extend all the way off that graph, edge to edge, and then we always finish it off with arrows to show it's going to extend forever and ever. That's it. My next equation, y equals 1/2 x minus 3. My slope is my m, or 1/2. So to define as my fraction, positive 1 is up 1, positive 2 is right 2. Then I have to do my y-intercept. We always take the sign in front. That's my b value. Notice this b is a -3. So when I go to graph that y-intercept, on that y-intercept, my first point goes to -3. So I drop a point at -3. And then my slope has told me how to move. It told me I move up 1, right 2, drop a point. Up 1, right 2, drop a point. And I repeat until I have enough points to form that line. My line is going to be nice and straight. Now, sometimes you run out of space, so we can always move in the opposite directions, which I would like to show you. The fraction 1/2 would be the same as -1 over -2. So rather than moving up right, I could also move the opposite direction, down left. And then it's going to help continue that line, because sometimes we have to do the opposite movements of my up and right movement to extend my graph if I run out of space. So from my y-intercept, I could have also moved down 1, left 2, drop a point, down 1, left 2, drop a point, down 1, left 2, drop a point, and it's going to be that same line. I'm still plotting dots on that same line, but just moving in the opposite direction, so that we can see that line all the way across the graph. Our next example you should be able to do on your own. So you should pause the video and then come back to check your answers with me. First, start by identifying your slope. Then identify your y-intercept, and then go ahead and graph. Pause the video, complete this on your own, and then we'll check this together. So when I identified my slope, I saw it was -3 and my y-intercept was 4. So to start graphing, we put y-intercept, look at my y-axis, find where it's 4, and drop our point. 1, 2, 3, 4. So I have my first point, easy peasy. But now when I think about my slope, it's -3. So when it says to define that slope, remember we write it as a fraction. My personal habit is to always put the negative with the top number. So I said -3 over 1. That's going to result in me moving down and to the right. However, you could also put your negative with the denominator. So you could say 3 over -1, where you would move up and to the left, and that would be perfectly fine as well. Opposite movements, but your negative is only with one of those values. It's either going to be with the top number, your numerator, or with the bottom number, the denominator. You're not going to put a negative with both, because then it'd be a positive number. So making sure you have that negative either with your numerator or your denominator, but not both, when you have a negative slope. So when I graph, I move down 3, 1, 2, 3, right 1, drop a point, down 3, right 1, drop a point, down 3, right 1, drop a point. Or I could have moved up 3, left 1, up 3, left 1. And then I have all my points to connect into that nice straight line, making sure I have arrows on both ends. So just be cautious when you have a negative slope that you're only making the numerator or denominator negative, not both. And then finally, sometimes it won't ask us to graph, but it may ask us to build a table. And we've built tables before, but just as a reminder, we're going to start the same way. If we're given an equation, we first want to identify my slope and my y-intercept. Looking at this equation, my slope is -1/2. So I could say it's either -1 over 2, or I could think of it as 1 over -2. That's up to you. And then my y-intercept is a +6. Now, when I'm putting points into a table, this is more like the first lesson we did in this unit. For my x values, I can really choose any x's I want. But because I have a fraction in my equation, I'm going to want to choose numbers that are multiples of that denominator. So my denominator is 2, so I want to choose multiples of 2. So maybe I'm going to choose -4, -2, 0, 2, and 4. I always like to choose some negatives, some positives, and always pick 0 because it's easy. But by choosing those numbers, I'm going to eliminate a lot of the fractions in the math that I do. To find the corresponding y values, I simply plug the x into my equation. So I'm going to plug a number into that spot. So for -4, I'm going to say -1/2 times -4 plus 6, and then I have to do the math. -1/2 times -4 is +2. 2 plus 6 is 8. Then -1/2 times -2 plus 6. This becomes +1. 1 plus 6 is 7. -1/2 times 0 plus 6. That becomes 0. 0 plus 6 is 6. And then you can finish for 2 and 4. So pause the video, find those answers, and come back and check. Okay, you should have those done. 2, you should have got the value of 5, and when you plug in 4, you should get 4. So that's just a reminder on how we build tables from equations as well.